Okay, AP Calc, I'm gonna do some of the problems from the accumulation packet, and then I'll do the rest of the problems in another video after you finish them. So for accumulation, we're using the fundamental theorem of calculus that tells us the integral from a to b of f prime of x dx equals f of b minus f of a. Okay, and sometimes in a problem they're going to ask you just what is f of b, and so we're going to change this equation around to be this, or we could write the f of a first. Let me write it that way because that might make more sense for when I talk about it. We can rewrite it like this, which means we're going to take where we start. This is where we start, and we're going to add the part at the end. Okay, so if you look at the example here, it says an example from the 2006 AB exam gives you a function that is a rate. Obviously, this is going to be a calculator question. You wouldn't have to find an integral of that. It says, here's the rate that the cars turn left per hour over the time interval from 0 to 18. To the nearest whole number, find the number of cars turning left at the intersection from 0 to 18. So to do that, we're just gonna take this integral, and you're gonna do that on your calculator. Make sure you know how to do that on your calculator, and you would get something like this. This is a rate, and this is like a whole. Okay, because when you take an integral of a rate, then you get the whole. Okay, and then what it talks about below is what I wrote there with the fundamental theorem of calculus, that the current equals initial plus plus the integral of the rate, and then we might have to, this is the rate going in, and then we would have to subtract out the rate going out. And we'll do some problems of those here so that you can see what that means. All right, so let's just do some of the examples. Let's do multiple choice problem 1. Here we have a graph with a line like this. And it says the graph of, and this is f prime. Make sure you know what the graph is. The graph of f prime, the derivative of f is shown on the figure above. If f of 0 equals 5, then what does f of 1 equal? Okay, well, remember that the integral of f prime equals f from a to b equals f of b minus f of a. And if f of b is, if we say, well, let's let b equal 1 and a equals 0, because those are the things that we're given here, we can substitute that in and say the integral from 0 to 1 of f prime of x dx equals f of 1 minus f of 0. Well, this is what we're looking for. That's what we don't know. We know this, and we can find this from looking at the graph. So f of 1 is what we don't know. F of 0 is 5. And the integral from 0 to 1 of f prime of x dx is just the area. Remember, integral is area. So we can find that by looking at this graph, by looking at the area of that rectangle or triangle, which is 1/2 6 times 1 which is 3. So that equals 3. So f of 1 equals 8, which is D. Let's see if I got it right. Well, I don't see the solutions right now, so I will just look for that in, oh, must be at the end. I'm sorry. I thought I had the solution sitting in front of me, but I don't. All right, well, I'll have to look for those. All right, that's number 1. Number 2, let's do number 2 in multiple choice. Pizza is heated to a temperature of 350 degrees, is taken out of an oven and placed in a 75-degree room temperature at T equals 0 minutes. The temperature of the pizza is changing at that rate. So what is the temperature of the pizza at time equals 5? So again, we have to see what we know. We know we have time equals 0 and we have time equals 5. We want to know the temperature at time equals 5. We know the temperature at time equals 0 is 350. And so to find this, we're going to take the integral from 0 to 5 of the rate of the temperature. The rate of the temperature is changing. And that's going to equal the temperature at 5 minus the temperature at 0. So we have to do this on our calculator. Let's see if I can do this. Sorry about that. Go ahead and put that in your calculator. Negative 110 e to the negative 0.4. And I'm sorry. You finish this one and see if you can find the answer, and I will do it also. I don't want to take up time right now doing that. All right, let's look at number 3. See if you can do number 3 by yourself. Okay, see if you can do number 3. Here we have acceleration and you're looking for velocity. It's the same type of thing. We're going to skip number 4. So far I want you to do number 2 and number 3. We're going to skip in the multiple choice. We're going to skip number 4 because that's a BC problem, and number 5 is a BC problem. Number 6 is a BC problem. You could do the next one. You could do number 90. And let's look at number 7. Okay. Let's look at number 7 where it has that graph. It says the flow of oil in barrels per hour through a pipeline is given by the graph above. Of the following, which best approximates the total number of barrel oils that pass through the pipeline that day? All you're doing is estimating the area under that curve. So you need to estimate that area, which is going to be, it's going to be, let's see, about, looks to me like it's about 3,000 if you're estimating the area under that curve. So that would be the answer to number 9. All right, let's look at the free response. So you got basically 2 multiple choice that I want you to work with. Now let's look at the free response. Okay, let's do number 1 together. All right, the tide removes sand from a beach at the rate of R of t. I'm not going to write it all out here. It's written there. This is how much the rate that the sand is going away from the beach. And then there's a pumping station that is adding sand at the rate of S of t. Both R and S have units of cubic yards per hour, and T is measured in hours for T between 0 and 6. Okay, and at time equals 0, we have 2,500, it's yards. We have 2,500 cubic yards of sand. How much sand will the tide remove from the beach during the 6-hour period? Indicate units of measure. Well, here's the rate. So we're going to take the integral from 0 to 6 of R of t dt. You need to write this down when you're doing your free response. Oh, there's my multiple choice. We need to write, you don't have to write out R of t, you can just write R of t, write that down, and then you can do that in your calculator, okay? Your AP test, you're gonna be able to use your calculator, you're gonna be able to use your notes, you're gonna be able to use any kind of book, anything on the internet. The only thing you cannot use is another person, but you only have 45 minutes. So don't rely on looking a bunch of stuff up. So if you do this on your calculator, you're going to get 31.815 or 816, depending on how they would take either one, they say here. And this is going to be your answer for the amount of sand that is removed from the beach. Okay, remember that you need 3 decimal places. For this, you would get 1 point for showing the integral, and you get 1 point for the answer with units. So let's look at the next part. Write an expression for y of t, so that's A. B, write an expression for y of t, the total number of cubic yards of sand on the beach at time t equals, at time t. All right, so y of t is going to equal 2,500, because that's how much we're starting with. Remember, right here, they told us that. Plus the integral from 0 to 6 of S of t minus R of t dt. Okay, does that make sense for you? Because here's what we start with. This is how much sand is being added to the beach. This is how much sand is being taken away from the beach. So if we take how much is being added, subtract how much is being taken away, and add that to the 2,500, then we get the amount of sand on the beach at time t equals at, oh, well, no, this is a little wrong. It said at time t equal, at time t, so we need to have this be t and probably these be x's or some other variable to show us that this is at time t. At time t equals 6 is what would have been here, what I had written before, but they want just a t in general. You could substitute in any t you want, so it's going to look like this. All right, let's see what you would have gotten for points for this. This you could have gotten 3 points. 1 point for this, the integral, 1 point, well, actually 1 point for this, the integrand, 1 point for the limits, and 1 point for the whole answer, which is everything right here, including the 2,500. Okay, let's see the next part. Right, let's see. Find the rate at which the total amount of sand on the beach is changing at time t equals 4. Okay, this is C. Let me use a different color. The amount, the rate at which the sand is changing. Well, remember in the last problem, we wrote an expression for the amount of sand, which was y of t, which was this. And so the rate would be the derivative of this, which derivative of that is just 0, and the derivative of this is just s of t minus r of t. But you definitely would not have to show that it's the derivative of that. The rate at which it's changing is the rate it's entering minus the rate that it's leaving. So that is an expression for it, but now we want that rate at time t equals 4. So we need to substitute in 4 for t, and go ahead and put that in your calculator. And you should get negative 1.908 or negative 1.909, depending on how you round that. And this, the units, don't forget the units, would be yards cubed per hour. It's a rate, remember? So your units have to be a rate. You get 1 point for this answer, this whole answer, the whole answer and the units for that one. And the next one, for t between 0 and 6, what time is the sand on the beach a minimum, and what is the minimum value? Okay, how do you find a minimum? We're looking for, remember, y of t is the amount of sand, on the beach. So we're looking for the minimum of y. That's what we're looking for. Now, we're looking for an absolute minimum, not a relative min, between 0 and 6. So remember, when you're looking for an absolute min, you check the end points, and then you check any points in between that are relative minimums. So we have to find the relative minimum of y of t, see if there are any. So we're going to take the derivative of that, which remember was s of t minus r of t, and we're going to set that equal to 0. So you're going to do that in your calculator, but you need to write this down so that they see this, that's what you're doing. You can do that in your calculator a lot of different ways. Okay, you can do s of t and r of t and see where they intersect. That would show where they're the same. Or you can take s of t minus r of t and look for a 0. They don't care. They're not going to look at that. That's just up to you. You're going to somehow find where they're the same. And you're going to find that at t equals 2492. No, that was wrong. That's the y, not the t. You're going to find that at t is 5.117865 or something like that, which is between 0 and 6. So you're going to put that on here, and you're going to substitute each one of these, 0 here and here, into your y value that you had from the other section. Now at 0, there's 2,500. We already decided that. And if you do that, you're going to get 2492.369 or something. and 2493.277, something around there. So where is it at a minimum? The sand is at a minimum here at T equals 5.118 hours, and the minimum is 2492.369 cubic yards. Okay, so I want you to do the next one, 2000 AB4. Okay, so you have two multiple choice, 2000 AB4, and it's going to be the same type of thing. Water is pumped into an underground rate at a tank at a constant rate. So it's pumped in. The rate it's pumped in is 8. Okay, there's no variable there. Water leaks out at a rate of the absolute value of T plus 1 between 0 and 120. At time equals T, at T equals 0, there is 30 gallons of water. All right, so I want you to do A, find out how many gallons leak out between 0 and 3, and then how many gallons are in the tank between 0 at 3. And then again, write an expression for the total number of gallons. That's like the one that we just did. And then find when the water is at a maximum. Okay, that's very similar to the one that we just did. So go ahead and do this problem by yourself, all the parts. Okay, let's look at the next one. Number 3, 2007 AB2. There's a graph. The amount of water in a storage tank is modeled by continuous function on the intervals T from 0 to 7. Okay, so we got water coming into the tank and water leaving the tank. It's a piecewise function for the water leaving the tank. The graphs of F and G, where F is the water coming into the tank and G is the water going out of the tank, intersect at T, at those two values of T. Okay, they're telling you, there's a graph there of those two functions, and they're telling you the values of T where they intersect, so you don't have to find them. So I would like you to do A, B, and C for that one. Okay, so you're going to do 2007 AB2. I want you to do that one. And let's see, how many more are there? Oh, there's just one more. There's number 4 here. 2010 AB2. There's no snow on Janet's driveway when snow begins to fall at midnight. From midnight to 9, it accumulates on the driveway by that function. And Janet starts removing snow at T equals 6. The rate at which that she removes snow from the driveway is there. Between 0 and 6, it's 0 because she isn't shoveling between 0 and 6. Between 6 and 7, she's taking it away much faster than she is between 7 and 9. Okay, they're constant. They're just different depending on what it is. How many cubic feet of snow have accumulated on the driveway by 6 a.m.? All right, let's start this one. How many feet of snow have accumulated by 6 a.m.? That's going to be 0 to 6 of f of t dt. Okay, she hasn't taken any away, so, and we don't have to add, we start with 0. There's none between at t equals 0, so we don't have to worry about that. So this is going to be, I'm sorry about that. this is going to be the answer to part A. So go ahead and find that for part A. Then for part B, find the rate of change of the volume of snow on the driveway at 8 a.m. Okay, so at 8 a.m., the rate that it's coming in is f of 8, and the rate it is going out is g of 8. That's all. That's all you have to do for part B. So see, some of them are not hard. Don't make them harder than they are. Then for part C, let H represent the total amount of snow that Janet has removed. There's a lot of typos in this. From the driveway at time t equals hours after midnight. Express H as a piecewise defined function with domain 0 to 9. Okay, so this is how much she has removed from the driveway. So let's look at this. This is H of 0 equals 0, right? Because she hasn't removed any yet. And then, let's see, what is it? That H represents the total amount of snow that she has removed from the driveway. All right. So between 0 and 6, H of t equals 0. Well, H of 0 plus the integral from 0 to 6 of g of t dt, or g, we shouldn't use t because t is our value over here, so use something else. And that equals the integral, this is 0, plus the integral from 0 to 6 of 0 dx, which is just 0. Okay, she doesn't remove anything. Then for t between 6 and 7, h of t equals h of 6 plus the integral from 6 to, oh, see, this should be a t. I'm bad at that. That's one of the things that I'm bad at, because this needs to match that. So because it could be any t between 6 and 7. So then between 6 and t of g of x dx, which equals 0, because h of 6 is 0, plus the integral from 0 to t 125 dx. And the integral of that is 125 x between 0 and t, which is just, oh, no, this is 6. Between t and 6, which is 125t, that's a 6, minus 125 times 6. And then between 7 and 9, h of t is the amount at 7 plus the integral from 7 to t of g of x dx, which equals 125, because when t equals 7, that's what this is going to equal, plus the integral from 7 to t of 108 dx. And then if you do that, you get 125 plus, I'll just write it like this, like that. So if you were going to write the piecewise function, it would be 0, 125 times t minus 6, and 125 plus 108 t minus 7 for these different values of t. Okay, and that would be your answer. And then, how many cubic feet are on the driveway at 9 a.m.? So we have to find that, we have to find how much snow is coming on the driveway between 0 and 9, and that's f of t. And then we have to take off how much snow is going off the driveway at 9, which is just h of 9 from the problem that we did up there. So you could do this on your calculator and you would get 26.334. And that is your answer. All right, so I want you to do those other problems that I told you that you need to do to finish this, and then I will go over the answers of these in another video.